Alright, so we're moving on to our next part, which is what we've been building up to, and we're going to actually start solving polynomials, which is what this whole unit technically is. Now, we do have a few steps that we're going to kind of list out here, and they're things we have been doing or have done before. So step one is what we've already been doing, and you're going to factor the polynomial completely. We worked on factoring last week, so you're going to choose one of those 5 ways depending on what's available, what the problem is to factor. Step 2 is you're then going to set each factor equal to 0. Step 3 is to then solve for x or whatever your variable is. Now, with that solving for x, sometimes they're easy, straightforward. Sometimes, though, if you still have a trinomial with x squared, you are going to have to use that quadratic formula that we used last semester. And just in case you forgot, I have listed it. So we have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and all of that is divided over 2a. So remember, these values all come from that standard form of a quadratic, and it comes from those coefficients. So you have a with the x squared, b with the linear, and then c is just the constant. So we're going to jump straight into an example. What's different here versus factoring is that your equations have to be equal to 0. So it'll either say equals 0, it'll say equals something else. If it does say equals something else, you do have to move everything to the left side so that it does equal 0. So then off to the right, I went ahead and wrote the 5 different ways that we're going to factor. Remember, this is the order that you check to see if you can factor. We start with the GCF, then difference of squares, trinomials, grouping, and then finally sum and difference of cubes. Now when I look at this, I start with GCF. I can't pull the same number or variable out. This isn't difference of squares. It's also not a trinomial, but I can factor this by grouping. So I'm going to go ahead and I'm going to group my first 2 terms together as well as my last 2 terms together. So I now have 3n cubed minus 2n squared plus 21n minus 14. Now looking at this first parentheses, this 3n cubed minus 2n squared, I can't take the same number out of the coefficients, but I can take n squared out of both of those. So when I take an n squared, or when I factor out an n squared, I'm left with 3n minus 2, plus when I look at the second parentheses, 21n minus 14, they don't both have a variable, so that means I'm going to factor something out of the coefficient, and I can actually divide them both by 7. And that also leaves me with 3n minus 2. I still have equals 0 with both of them because we are solving here. So remember, at this point, you're going to look at them as 2 groups. We have the first one that I've underlined in red and the second one in that teal color. Now when I look at them, what do they have in common? And if you notice, both of them have that 3n minus 2. So I'm actually going to pull that out into my first parentheses. So 3n minus 2. Now I'm kind of going to cross it out because I already used it. And in my second parentheses, I write whatever is left. So from this first group, I still have n squared left. And then from the second group, I still have that plus 7. So I've officially factored this as far as it will go. I now have to go on to solving. So like we said in your steps, your first step was to factor completely, which we've done. Step 2 is to set each factor equal to 0. So I'm going to take this 3n minus 2 and set it equal to 0. And I'm going to do the same thing with the other factor, n squared plus 7, and it's equal to 0. I'm now going to solve each of these for the variable. So in this first one, 3n minus 2, I'm going to add 2 to both sides. So I end up with 3n is equal to positive 2. And then my last step is to divide both sides by 3. So n is equal to 2/3. Now in the second one, I'm going to subtract 7 from both sides. So I get n squared is equal to negative 7. I'm going to then take the square root of both sides. So I end up with n is equal to the square root of negative 7. Now, before we couldn't take the square root of a negative number. When you have a negative on the inside, you need to remember you leave the number and bring an I on the outside. When you're taking the square root as well, you have to have plus and minus. So I end up with n is equal to plus or minus the square root of 7i. So technically I have one answer here with the 2/3, and then I have 2 answers in the second one. When I look at my original problem, my highest exponent I had was a cube or a 3, so that tells me that I should be having 3 answers in the end. If we were just factoring, we would have stopped here with the parentheses, but because we're solving, we're going to take it all the way down until we have the variable equals numbers, i's, just depending on whatever it is. So again, in this situation, we are solving. Remember, I told you that it had to equal 0, so I'm going to subtract 8 from both sides. So I now have 3n squared plus 10n minus 8 is equal to 0. Once it is equal to 0, I can now start my actual process. I'm going to start factoring first. There isn't a GCF, this isn't difference of squares, but there are 3 terms, which means it is a trinomial. When I look at the coefficient with the squared, it is greater than 1. So I'm going to take 3 and I'm going to multiply it by that negative 8, and that's going to give me a negative 24. I'm now going to list out all those factors. So I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. There's nothing for 5, and then 6 repeats. So I'm done listing my factors. Now, when I add or subtract these, they have to equal this positive 10 in the middle. I can't do that with 1 and 24. I could do it with 2 and 12 if I have a negative on the 2. I can't with 3 and 8. And I could with 4 and 6 if they're both positive. This is where you have to be careful though, because when I multiply these two numbers together, they have to give me that negative 24. So negative 2 times 12 does give me negative 24, but positive 4 times positive 6 gives me a positive 24. So I can't use that pairing. I'm going to take those 2 factors that I have, so I have negative 2 and positive 12, and this is when we divide them by that a value, so 3 and 3. And we have to reduce our fractions as far as we can. This first fraction doesn't reduce, so we leave it as negative 2 over 3, but the second one does. 12 divided by 3 gives me 4, but I need to leave it as a fraction, so it's going to stay as 4 over 1. Now to write these, remember we have our 2 parentheses. They're still equal to 0 from the original problem. I take the denominator and it goes with my variable. So I'm going to have 3n, and then I have the numerator with its sign. So 3n minus 2. And the second parentheses, I take the denominator, which is 1. So it would be 1n, or in this case, I'm just going to put n. And then I have the numerator with its sign, so plus 4. I have factored this completely, so then I'm going to take each factor and set it equal to 0. So 3n minus 2 equals 0, n plus 4 equals 0, and we're going to continue on the process we did before. For the one on the left, I'm going to add 2 to both sides, so I end up with 3n equals 2, and then I'm going to divide both sides by 3, so n is equal to 2/3. And then for the second one, I'm going to subtract 4 from both sides, so n is equal to negative 4. So these are my 2 answers, n equals negative 4, and n equals 2/3. So this last example I'm going to do is actually the one that's probably going to be the longest out of all the examples we have. We're still going to start with our factoring, and we're going to start with our GCF. I can actually divide both of these by 3, and when I do that, I'm left with 8x cubed minus 27, and it's still equal to 0. So now I actually have a difference of cube because I can rewrite 8x cubed as 2x cubed and then 27 as 3 cubed. I still have the 3 on the outside and it's equal to 0. So remember your formula for difference of cubes. If you have a cubed minus b cubed, it's equal to a minus b times a squared plus ab plus b squared. And so in this situation, 2x is your a, 3 is your b. So I still have that 3 on the outside all by itself. In the first parentheses, I have a minus b, which would be 2x minus 3. In the second parentheses, I'm going to square a, so 2x times 2x is going to give me 4x squared. Plus, I'm now going to multiply a and b together, so 2x times 3 gives me 6x. Plus, I do b squared, which is 3 times 3, and I get 9. And it's still equal to 0. So at this point, everything is factored completely. So I'm going to take all my factors, and I'm going to set them equal to 0. You have to be really careful with these numbers out front, because if I go and I set 3 is equal to 0, that is not a true statement. So if you have a number out front by itself, just a number, then that isn't a factor. It doesn't give you a 0. I'm going to go with the second one, which is the 2x minus 3. So 2x minus 3 equals 0. Add 3, you get 2x is equal to 3, and then divide, so you get x is equal to 3 halves. Now on the third factor that we have 4x squared plus 6x plus 9 is equal to 0. This isn't a straightforward one where we can start adding and subtracting. This is actually one where you're going to have to use the quadratic formula. So remember I gave that to you. You have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I need to identify what each of these numbers are from what we have as our factor. So when I look, my a is going to be 4, my b is going to be 6, and my c is going to be 9. So I have x is equal to the opposite of, so I have 6, it's now going to be a negative 6 plus or minus the square root of, my b again is 6, so 6 squared, minus 4 times a, which is 4, times c, which is that positive 9. And all of that is underneath that square root sign. And then remember, we divided all by 2 times a, so a is my 4. I can start reducing, and I actually do it in pieces. If you do it on your calculator, you have to be careful because sometimes you'll get an error, and in this situation, you will get an error. So I still have x is equal to negative 6 plus or minus. I actually plug 6 squared minus 4 times 9 without the square root into the calculator to see what that is reduced. When I do, I get the square root of negative 108. And that's all divided by 4. At this point too, you have x is equal to negative 6 plus or minus. I would not reduce the 108, but I would, and you have to take that negative out and turn it into an I. And it's all over 8. Now you can reduce this further if you choose to. I would just leave it as is and leave this as your answer. So in this situation, we have or should have 3 answers because of the cube. We have the one where x is equal to 3 halves, and you have to remember this quadratic formula because of the plus or minus gives us 2 answers. So I do have 3 answers here. So you need to get the assignment from the sub. You will turn it back in at the end of class. If you do not, you will get a 0 that cannot be made up for a minor grade.